Hello everyone, welcome to this series on how to build your very own Linux distribution absolutely from scratch. And last video we ended up with downloading, configuring and installing busybox. We also provided the rudimentary root file system, so we will continue from that video. So just go to the working directory, which is called Linux, and just to recall what is there. So you see this root folder. So if I cd to the root and see what is here, so we have this rudimentary init script here that just runs the ctty shell, which is good, but this is not yet capable of handling events like reboot or poweroff. And also another issue that the system doesn't yet support networking. So these two topics are the major that we're supposed to be covering within this video. So make a more appropriate init and also set up networking. But before that, I probably want to create a couple more scripts here. So since we're supposed to be recompiling the root file system many times, and also we'll need to run this. So I just want to create a file called run shell. So we open with the bin bash. So just for the ease of running things, so here I want to say qemu system x86_64, hence since we're dealing with a 64-bit system here. No graphic because I want to run this in a terminal. I want to use cursors for rendering instead of SDL. I provide the CD-ROM called msmd-linux.iso and want to give it 1 gig of memory. Here I want to enable KVM. Okay, and already I just want to make it now if I want to escape from this emulation, it just restart the terminal, which is not really handy. So I want to be able to do the power off so that it naturally exits. And also, probably, I just want to create another script here. So let's call it build root, just containing a single command. So say bin bash, and here I want to cd to the root. Then when I'm done, I want to cd back. Probably I cannot even do that, but anyway. So while I am not cd to the root like this. So while being in the root, I want to say find all and pipe the output of that to cpio -o -h new c, and pipe this to gzip, and this is going one level up and to the ISO folder and to the boot, and the output is root.cpio.gz. Right, quit, make it executable, build root. Now let's go to ISO boot and remove the root cpio.gz, go back, and if I now do my build root, I want to list whatever is happening within the ISO boot, and so it exactly puts the updated image there. So we didn't yet update anything, but so now the matter of updating the image would be just running this build root shell that would be running this single command to pack root file system into the cpio.gz format, which is essentially the root the init ramfs sort of thing. Okay, so now we can start altering the initialization files and add more files and alter the init itself. So if I say VICI init, so here you see we're just starting the shell here. So instead we want to use the busybox init. So here I want to say start busybox init. So busybox init is the part of the busybox that's the applet that allows you to sort of listen to the events like when the user is trying to escape from the shell, like to handle this scenario when the PAD1 is sort of trying to be closed, which results in kernel panic. So that's not about to happen. So when we want to reboot, power off. So it's essentially, like, that's the middleware that allows you to deal with the operating system events, mostly dealing to just load and unload the system. So instead of directly executing ctty hack, I want to execute sbin init. Right, and now when we do enable this sbin init, so we only have the ats folder, so let's create it mkdir folder called ats and cd there. So sbin init from busybox relies on the file called inittab. So let's create one under the ats folder. That's where the sbin init is looking for that file. So I call the file inittab, right? And here I do the following thing. So on the event called sysinit, I want to, well, first let's just clear the screen. Then I want to, well, we can bring some logo to the screen. So just say cat and ats logo txt. We don't yet have the logo file being there. We will copy that file into the rootfs ats directory a bit later. So we want to clear the screen, print the logo. Then on restart, we want to invoke the sbin init again. So every time restart happens, this sbin init to handle everything. Then another scenario, so the shutdown. On shutdown, we want to sync. On shutdown, we want to unmount all. Well, it might give an error because, literally, it would not be capable of unmounting dev, for instance, the dev template file system, and yeah. But if you just mount some the real SSD drive or HDD drive on the real hardware, in this case, this might be quite useful to unmount that before you escape. Okay, so shut down these two scenarios. Then another one, ctrl alt del. So control alt del. When user is pressing control alt del, it just does the sbin reboot, because essentially we do want to reboot when we press control alt del. And finally, last but not least, is respawn. So every time the user tries to exit from the shell, so this is going to happen, or when the user or when the system boots for the very first time, it would also call this. I want to call the bin ctty hack, and it will call the shell. Well, later we can do this even in a more sophisticated way. We'll be able to call things like ats shell.sh. Because say we want to start the shell with some pre-installed environmental variables. In that case, we cannot just do say environmental variable equals to something and then start the shell. This is not syntactically correct. But we can call the shell script shell.sh that would leave, let's say, in ats folder. Yeah. It will not provide that as well. So that's just a bit more flexible way of doing things. So right, quit. Now let's create the shell.sh. And here, just want to, I don't even specify that, yeah. So just say, just example. So let's create some environmental variable equals to test, for instance, and we just call the bin shell after. So yeah, right, quit, and a problem. I'm not sure if I need to make this one executable, but yeah, I would actually make it executable. won't be that bad. Okay, so the logo, we also mentioned the logo. So I just copy from the monkey see monkey do Linux repository that I've downloaded to home cmk desktop monkey see monkey do Linux. I guess ini and logo.txt, copy here. And now we have the logo here. So just to see what is there in logo, this cute monkey see monkey do logo would now be visible on system start. Okay, so I think we can already try to test this. So cd to the working directory. Let's build root. Okay, so it now has more blocks, which is okay because we just added a couple of files. And let's run this. And now, if I did everything properly, I should already be capable of like doing things like poweroff. Let's check that quickly. Okay, so we don't even have the S folder. That means that the root file system wasn't correctly updated. Let's have a look why that has happened. Oh, that's happening because I forgot to update the ISO image. Yeah, obviously. Yeah, it was all fine with the creating the root file system, but yeah, I just forgot to update the ISO. So if I do the build root again, so probably let's even call this let's call the build root rename to build ISO .shell. So yes, open the build ISO. And now, yes, we still need to go one level up. Now I can say grub mk rescue -o msmd linux.iso. So this is going to be overriding the existing ISO image. And the source is the ISO like this. Right, quit. And just run it. Yeah, now if I do run, it should already work on the updated version. Okay, yeah, exactly, cool. So now you see, like, we no longer have this TCY issue, like didn't find the TCY to work on. Alas, here then we see that the ads folder is now there, so cd to the ads folder. So we can get the init tab that we've created, it's over in here. We have the logo also being available, and the shell. So let's have a look at cat shell. So we should have the environmental variable called env. So if I just say export, yeah, we do have the env equals to test, which is fantastic. So when it comes to installing some software that relies on environmental variables, like for instance the Golang, Go programming language, it would need to have the variables core root being exported as the environmental variable that is that corresponds to the current session of the shell running, and also the folder containing the binary with the Go compiler also needs to be added to the path variable. So that is something to be done when we would be installing the Golang development environment. But for now, I just wanted to make sure that we can indeed have some custom environmental variables, which is really cool. Okay, great. So now let's try to reboot. And yeah, you see, like sbin init handles properly all this stuff, and we can reboot, and it boots again. And if I say power off, it would now turn off like the system and escape gracefully. Yes, great. Okay, now we go down with the initialization stuff, and we can already start working on the networking. Yeah, so I just cd to the root. Okay, and I say VICI init. So let's add some more lines here. So just before starting the busybox, well, it's not really probably the best ever way of doing things, because this would only be capable of detecting the network on boot. So if you say do the hop block of the Ethernet cable, it's not going to see any changes. So you need to plug the cable, reboot the system, and then you will get connected to the network. So this might not be the best ever practice to go, but I just want to show the proof of concept of how one can actually achieve the networking. So I'm going to write the code specific to setting up the networking just before the sbin init goes. So here I just say setup networking, and we want to loop over the network devices. So I can say for netdev. I should have probably shown you the network devices, but if you just run if config -a, then you'll see, oh, actually I did show in the previous video under the sys file system, sysfs, yeah, sys class net, and there were the network interfaces. So I actually did show this to you. So for a net device in that exact thing, so sys class net and all the device loop over all the devices available there, want to do the following thing. So here, want to say first like echo found network device, and then want to specify the name. So I say the netdev and hash whatever goes there. So it would bring the networking device. Now I want to say IP link set and the certain netdev hash like this. I want to say up. So this line essentially turns the networking device on, which is quite essential. And in case if a given device is not the loop back, so say if netdev hash this, if it's not equal to LO, okay, loop back, it's not that. In this case, so the following condition like means true, so this is true. Then we want to use the udhcpc, which is the standard busybox applets, the DHCP sort of client, and the parameters -b. Want to run it in the background -I. Want to get the IP address from like all the parameters from the network, and again this netdev hash like this. Okay, and also as a callback, we want to call the script that would actually do all the setup. So we'll call the script that would be located at the and called network.shell, right? So now we need to provide the network shell script. So we go to the directory, and here let's create one called network.shell bin shell. So the idea is that when the udhcpc applet calls the callback script, it also creates the environmental variables containing the IP, the mask, and the interface. So we can directly reference those the following way. So I can say IP. So setting the address, we want to add one, and we use the environmental variable IP. Again, this is being initialized by the udhcpc. So without that, IP just doesn't exist. But udhcpc does, in particular, indeed initialize the IP with an IP that udhcp client gets from the network your device is connected to. So the IP and the mask. So the mask is using some interesting format, like it won't tell you 255.255.255.0. It will just tell you 24, which is sort of encode the 255 stuff But when you use the if config to see the mask would be turned into the 255 stuff back again. So just for the convenience of seeing that. So hopefully that makes sense. So you might be a little bit confused when the mask is equal to something like 24. So what is that? It's just a matter of encoding. So that's okay. And then the device to reference this IP with is going to be the interface. So interface would be either F0, Ethernet 0, or you might have some else, but this is somewhere else. But essentially, F0 is the most essential one. And also, I want to say that if we have the variable router being equal to true, in this case, we just do the following. In this case, we just do IP root at default, okay? And want to do this via this router, okay? And using the dev interface, right? And that's it. And finally, just to bring a bit of debugging information. So here we can essentially say that setup IP address and mask IP address and mask, and here want just to print some debug info and just say, so if the environmental variable IP indeed exists. So in this case, we just want to print the following. So I can say echo -e to use the escape characters. So DHCP configuration for device, and then specify the interface. Okay, and just so here I say the IP, yeah, probably. So IP is going to be equal to I want to make it like bright white, so that's the escape code for that, and then the IP, and so just printing some escape sequences that allow to change the colors in the terminal, and also want to have the mask, and also want to see the router. Okay, so here we use the mask, here we use the router. Yeah, and that essentially should be it if I didn't make any typos. Hold on a sec. I'm just wondering, probably shell is not executable. Yes, I need to make it executable. Not the shell, but network. So network shell. Yeah, okay, and obviously not the if, but the if the IP is actually available. So that's the reason why the message was not printed. So now this should actually work. So let's try to build the ISO and run. Okay. Yeah, now we have the IP being received, the mask and the root. Root is 10.0.2.2. Great. So if I say if config and f0, yeah, then we have the internet address being 10.0.2.15, mask 255.255.255.0. Yeah, everything now works nicely. So we have the received bytes 742. transfer 1.2 kilobytes. So yeah, we can now try to run the ping command. That's been the Google DNS server. Okay, and ping actually works, which is fantastic, which proves that we do have the network now being set here. And I've been also testing this on the real hardware, so it works like a charm there as well, just to make sure that you plug in the Ethernet cable when the laptop is like turned off. So then you turn on with the Ethernet cable being plugged in, so that on boot the UDHCP is capable of setting up the IP address properly. So like the number of received bytes are X2178, which proves that the network is actually working. That's fantastic. Okay, guys, so now still we have the issue that even though the network is working, we cannot do the like outgoing requests to say like if we want to get the HTML response, or if we want to get some file being downloaded from internet. So we don't have widget because, like you remember, we have disabled this. So there is a workaround for this, and I will now show you. We'll now install a couple more packages into our newly created Linux distribution. So let me just power off from here. So yeah, we are in the current working directory now, and I can simply say git clone and https github.com / my username / the utility is called get. Okay, and here is the get. So if we cd into the get and into the source, so here is the project. We have the binary executable there already, which is called get, but I just want to show the source code. So this utility allows us to either download files from internet or just to get the HTML response from the target URL. So the way it's done is the following. So first we need to create a custom DNS resolver with a specific server address, and we're using here 8.8.8.8 con53 port number 53, which is the Google's public DNS server. Okay, so just set a timeout to the dialer, so if it just doesn't connect within 10 seconds, it just will not work. Okay, then we modify the standard going HTTP client with a custom DNS resolver, and we also do skip the certification testing. So that's a little bit insecure, but again, this just works straightforward, and for the educational didactic needs we are looking for here, this is fairly enough. So under the dial context, we created the function sets the dialer, again the timeout, and the resolver in this case equals to the resolver that we just created previously. So uses the custom resolver. So this is the custom HTTP client that is using the custom resolver. And also important setting here that it just drops the this TLS config, so insecure skip verify equals to true. So this allows you not having any certificates, so just go straight ahead to where the target URL is, wherever it is, and just downloads content from that, and that's it. Now a simple interface. So URL to make the get request to. So it can be either obtained from the command line arguments, from the very first command line argument, or otherwise it can be used within the pipelines, like if you're using some bash script and you just want to use the output of one command as the input HTTP address for the get command. That is also possible. We'll demonstrate how that is working. And finally, we do make the HTTP request to the target URL. So if it's not possible to get something from there, it just gives an error. Otherwise, yeah, just reads the bytes from the response body and prints them to the standard output. And if we redirect the output from the standard output to file, that's how we can achieve a file download. So that's a very nice thing to have. I already have this being compiled into a binary. So I just want to show you the build shell. So here, what is interesting, we're using tags net go. So if you don't do this tags net go in this case, still your binary executable would rely on libnss underscore DNS, which is not the case for us because that's the reason why we dropped the widget support from busybox. So, but if you use the minus tags net go, in this case, you will have an absolutely 100% pure ELF binary. So let me just delete. So rm get. Okay, so we no longer have it, and now I just want to build it again. All right, so now we have the get executable, and I say alt D to see the dependencies, the dynamic dependencies of the get, and not a dynamic executable, which is absolutely what we've been looking for. So now we can just simply copy this get to our root file system. So let me show you quickly how that can be done. So we just cd to the root, and we cd to the user and bin. Okay, and right over in here, we just say cp level up to user, level up to root, level up to Linux. Then it's called get source and get. Okay, and just copy here. And now let's grab and looking for get. Yeah, so we have the get here now being embedded. And also, I really want to use my cool VICI text editor under this newly created Linux distribution. So I can also copy that as well, since that's just a single binary executable. Let me quickly, well, probably, yeah, I just copy this first and then quickly show the source code. Probably not something you would be interested in, but anyway, I liked advertising my text editor because I feel it's really cool because I'm using it on my very own. So copy, use the absolute path here because I've already, well, actually, yeah, okay, I just already downloaded it. So home, CMK, desktop, and it's called VICI, source, and the file called VICI, and put it here. So ls and grab, so just to make sure it has been installed. Okay, and now we can again build the ISO and run. And now already we should have. Was there any error? What? Oh, I'm not sure whether something went wrong or not. To be very honest. Yeah, the boot went a bit strange. Yeah, but still obtains the IP address, hopefully. Okay. Okay, let's try my text editor. Okay, yeah, we have the VICI here available. So for instance, edit init. Yes, and we got the init here. Yeah, it just doesn't use, it doesn't, the emulator for some reason doesn't react to the arrow key, so I can use hjkl instead, and comma and dot for the same, but go into home and page up, page down. Yeah, so it's actually here, which is cool. And also we should be having the get. So if I just invoke get, it assumes that I would input the address, that the URL as this to the standard input. So I can say https and example.com. And yeah, we got the HTML response from example.com, which is cool. So for instance, yeah, we don't yet have the home directory. We'll create one when it comes to installing the Golang programming language. It's going to happen in the next video, but for now it's just, I don't know, let's just mk the home. Although it's not the real home, because if you have a look at the export, then the home is treated to, so root is treated to be as home now. So just to give you an idea, say like home is, the root is now home. But anyway, so let's cd to our newly created home, and here I can say get, and now we can also provide the target URL as the command line argument. So let's say example .com, and I want to redirect this to example.html. Okay, and we have the example HTML file, which we can now open with a text editor. Fantastically good. So yeah, we can see what we got here. It's really amazing. And also, what is even more cool, with this get sort of utility, we can install whatever static binaries we have. So there is a very nice project called MinOS or minus, so operating system that like relies on the static binaries. So it has the repository with the archives containing the static binary. So let's say we want to install Vim, but in order to do this, we need the statically linked one. So I can say get and HTTP. I'm not sure HTTPS or HTTP. We'll now figure this out. So it goes as.mainos.io/archive. Let's have a look. Yes, probably HTTP, not the HTTPS. Come on. Okay, yeah. And here are the mirrors. So we'll use the one called Bifrost. So Bifrost, okay. And we're interested in 64-bit executables. So we go to x86_64. And here we have a hell lot of different packages. So if say you want to search for a package, so say I want to install Vim, I just can say grep Vim. And if Vim is actually available there, then yeah, it gives me the options to download. So for instance, I want to use this Vim tar.gz64. So I can say Vim -7.3-1.tar.gz. And I want to save it, to download this to the file called vim.tar.gz. Okay, and it downloads. Okay, so now we got our Vim here. So now I can do tar -xvf and Vim, and it extracts the files. So the user folder, so that's cd to the user, and well, we're interested in the binary ones, so cd to the bin. Here are the Vim binaries. Well, essentially just Vim is enough, so we just say cd Vim to root user and bin, so literally installing Vim. Oh, not cd but cp, obviously. cp. And now let's clear the screen, and wherever repository we are currently at, I can say now Vim, and ta-da, we got Vim. So insert mode, and yeah, we just do some Vim stuff. So let's say edit root init. Yes, that's because I need to override stuff. So I don't know, edit -e. Is that the case? I don't remember. I'm not a Vim user. Yeah, that's the case. Yeah, arrow keys are also not working as Vim for this under this emulator, but HDKL works like a champ. So yeah, for those Vim fans, this is the case. So you can download Hello Software. Well, you cannot use CURL and widget from this repository because they are not working due to the same reasons regarding the libNSS on Disco DNS. But all the other like Vim or those not dealing with networking, in that perspective, like how the widget and CURL does. This might become really handy. So essentially what we have here after, just try to escape from here, is, so essentially what we got here is a minimal working Linux operating system with networking where you can download files. Well, obviously you cannot use Git here because again, this complicated or authentication, all this stuff. So like push into the repository, all this stuff, the certificates, fucking security, yeah, it's complicated, so it's not going to work. But yeah, you can still download something from internet, even if you want to download some code from GitHub. I just want to show you this. So I do cd to make, cd to home, and I can still download some code from GitHub. So for instance, I can say get and https and github.com, not as a git, but as the zip archive. So say my username and say my VICI text editor, for instance, and or even better, this get that we're using. And I want to say archive refs slash hats slash main zip, if I'm not mistaken. Is that the case? I just don't want to print this to the standard input, to the standard output. I want to save this as get.zip. Okay. And let's see. Yeah, we have the get.zip, and I want to unzip get.zip, and we have this get main, so cd to the get main and cd to the source. So yeah, it's not a git, it's just the cloned archive, but we can still have a look at the source code, for instance. And in the next video, what we're supposed to be doing, we will install Golang so that we would not only be capable of observing this Go source files, but we'll also be capable of compiling this. So literally like sort of a development environment. And yeah, we'll be capable of writing some programs and compiling them. Okay guys, so this is it from my side. I hope you enjoyed the video and found some useful bits in it. So thanks for watching, and I'll see you in the next tutorial.